Raise your hand if you're from Colorado. Keep it raised if you ski or snowboard. In the past year, there have been 6,163,278 skier visits to the current CSC USA, Colorado Ski Country USA, member resorts. And why is that? Because the snow in Colorado is the perfect type for those winter sports. It is light and powdery without ice to cut into the boards. The cause, of course, is humidity, or in the case of Colorado, the lack of it. Humidity is the amount of water vapor in the air. Water vapor comes from the evaporation of a liquid and requires heat energy to change the state of the water. Relative humidity is given as a percentage and is the ratio of the amount of water vapor present in the atmosphere to the saturation point in that area. The saturation point is dependent on the energy from heat or the current temperature. Therefore, when the temperature is cooler, it takes less water vapor in the air to reach the maximum saturation point. When the temperature is higher, in order to reach the maximum saturation point, there must be more evaporation occurring to increase the amount of water vapor. For instance, snowmaking conditions of 20 degrees Fahrenheit with 10% humidity are the same as those of 20 degrees Fahrenheit with 90% humidity, because even though the relative humidity is not the same, they both consist of the same amount of water vapor. One way that the combination of temperature and water vapor affects snow is in controlling the amount of change experienced in temperatures throughout the day and night. This can be attributed to the properties of specific heat, which is the amount of energy required to raise the temperature of 1 gram of a substance by 1 degree. Water has a specific heat of 1, whereas air has a specific heat of 0.24, and sand has a specific heat of 0.19. Because the specific heat of water is higher, it takes in more energy and releases it slower. This regulates the change in temperatures and keeps it more stable. In areas with high temperatures near water, such as Baltimore, Maryland, the high temperatures cause more water to evaporate and subsequently create more water vapor and higher humidity. The humidity in the air regulates the temperatures due to the specific heat of water, causing the temperature to be fairly consistent between day and night. In Denver, the low humidity is caused by lesser amount of water vapor in the air, which means that the temperature is less regulated and that the difference in temperature between day and night is much more drastic. The less stable weather conditions allow for temperatures to fall below freezing, so that when water vapor condenses and turns into precipitation, it is released as snow. Not only does the amount of water vapor in the air affect the temperatures that are conducive to snow, but also the saturation levels that produce precipitation. In Denver, when the night temperatures fall, the saturation point decreases to the point where less evaporation is required to have sufficient water vapor in the air for the saturation point to reach 100%, forcing precipitation. For this reason, snowfall is more common in Colorado, where less moisture is needed to produce the same results as other areas. As previously stated, humidity not only affects the amount of snowfall in an area, but also the type of snow. When air contains an excess of water vapor, as it does in many areas on the East Coast, the snow that is formed also contains extra moisture, causing a much denser and heavier type of snow. The snow is often perfect for activities such as making snowmen or having snowball fights, because it is easier to form together. However, in areas similar to Denver, where the air does not contain as much water vapor, the snow that is formed is much lighter, without the weight of the excess moisture. In general, about 10 inches of snow becomes an inch of water after it melts, but this does not hold true for all areas. In Mount Washington, New Hampshire, for example, it only takes 5.5 inches of snow to melt into an inch of water, whereas it takes over 15 inches of snow in Crested Butte, Colorado to have the same. The saturation point also affects the type of snow because of the rate of evaporation. When water releases heat, it evaporates and cools itself down. In areas with higher saturation points, where the air is already too saturated or too humid to collect more water vapor, the water cannot cool as fast. When the humidity is low, however, the water can cool off much faster. Colder snow is also lighter, which increases the compression of the snow, or the depth of the snowpack, which is a very important aspect of winter sports. All of this, however, has the potential to change. In the span of 28 years, from 1976 to 2004, the Earth's average temperature increased by 0.9 degrees Fahrenheit. In that same time span, there was a 2.2% increase in the amount of atmospheric water vapor on a global scale. A climate researcher by the name of Nathan Gillette estimates that by 2100, there could be a 10% increase in humidity levels. Much of this is caused by the global warming positive feedback cycle. As increased levels of CO2 enter the atmosphere, the greenhouse effect causes overall temperatures to rise. As temperatures rise, so does the rate of evaporation. This leads to an increase in water vapor, which is also a greenhouse gas, further contributing to the rising of the Earth's temperature. The cycle continues with no end in sight. The rise of temperature has been evident in many high-altitude Colorado cities, such as Fort Collins, whose average annual temperature has increased by 4.1 degrees Fahrenheit. Precipitation has and will continue to increase, released as rain instead of snow. The economic consequences of these findings are huge for Colorado. Colorado is the #1 ski and snowboard state in America, and dominates 23.1% of the market share. In 2007, it was estimated to generate $1.92 billion annually, which was largely made up of winter ski-associated tourist activity. If the current greenhouse gas emission rate were to continue, and in the year 2100 we reached a level of 700 ppm of CO2, the Colorado snow season would potentially be 30 days shorter. Although it may seem insignificant to some, the results for the state of Colorado would be drastic. To maintain their profit level, ski resorts count on at least 100 to 105 ski days, and without this, their revenues decrease dramatically. In 2008, the Vail Ski Resort reported a loss of $2 million in profit compared to 2007, due to the lack of snowfall. If tourist activity decreases a mere 1% annually, it is estimated that by 2017, Colorado will see an economic loss of $275 million and a job loss of over 4,500. And like how long?
I'm Wyatt. I've been skiing since I was about 4, and I don't know, the snow in Colorado is way lighter than like the snow back east. Snow back east is really heavy and wet, and there's not so much powder. It's more packed and icy, and here we get more powder, and it's really soft and fluffy snow.
So you prefer the snow here?
I prefer the snow here.
Do you have any idea why that is?
I would say here it's drier, so we don't get So we don't get the heavy snow. It's a dry snow, so that's what makes it lighter, I guess.
Hi, I'm Maddie. I'm from Texas. My whole family is from Wisconsin, though. Snow in Wisconsin is a lot different from snow here. It's a little wetter. It's definitely easier to pack there, which I guess is a good thing because you don't want as much packed snow when you're snowboarding on it and hurt to fall on. It's also hard to ski and snowboard in Wisconsin because there's not as many hills as mountains as in Colorado. So,
why do you think it's more wet snow in Wisconsin as opposed to dry snow here?
Probably just the climate and the altitude.
Alright, I'm Adam Cullen from Vermont, and the snow is much more powdery here and much icier back out east.
Where back east have you?
Vermont, Stowe, Mad River, stuff like that.
Okay.
Skiing in Vermont.
So you prefer it here?
Then I went skiing Breck here. I think I prefer it here, yeah.
Yeah. And why do you think there's a difference in the snow?
Mountains are taller, it's colder, I don't know.